Good evening, Earth Science students. Today's teaching point is to identify a stream's profile when it meanders versus a straightaway. During the course of this video, please open up your notebook and write the following: 1. Teaching point in the table of contents, 2. Teaching point for your notes, and 3. Notes that are in yellow font. Vocab terms will be given by your instructor to include in your glossary at the back of your book, or in the back of your book. Alright, so vocab terms. First one, stream vocabulary. We have a channel, the path that a stream follows. If you notice that in this path here is a nice straight path, which means that this stream is probably a pretty young stream if it flows straight. Next term we have is meanders, the curvature or bends in a stream's channel. If you notice that the meander, right, the stream goes straight and then it curves here. So we have one meander, a second meander, a third, a fourth, a fifth, a sixth, all the way down, and it looks like it continues past this picture. Alright, so these are many meanders in a stream. Alright, so stream bank edge. As the stream becomes older, mature to old age, the stream will begin to meander, causing differences in velocity. Let's take a look at some examples.
In meandering streams, erosion and deposition occur at the banks. Point bars form where slow-moving water deposits fine material. Cut banks occur where faster-moving water erodes away bank materials. At the outside of a bend, the water flows faster than the water on the inside of the bend.
So in this picture here, we have the outside, right? The outside here would have the bigger curve. The inside bend would be here. So on the inside, the stream velocity decreases, and your stream velocity increases along the outside edge of the bank.
The channel cross-section is asymmetrical, with shallow water on the inside of bends and deeper water on the outside of bends.
Alright, so in this case here in this diagram we have B and A, right? So letter B was the outside curve, which is here, where the water is faster and more erosion. You have a steeper bank by B. By A, on the inside curve, we have more deposition. In this case, by letter A, the gradient will be more gentle.
As we move downstream, the path of the deepest flowing water moves to the opposite bank. Therefore, erosion still occurs on the outside of the bend, and deposition occurs on the inside.
So sometimes, depending on the meander, right, we have to figure out which one is the outside curve and which one is the inside curves. And again, sometimes, you have the outside curve here, and then it transitions to the outside curve on the next meander.
The channel cross-section is still asymmetrical, with shallow water on the inside of bends and deeper water on the outside of bends. However, the areas of erosion and deposition occur on opposite banks to the first bend.
Alright, so in this case, letter B, right, on this outside curve, it's going to be a steeper gradient because of erosion. By A, on the inside curve, where water velocity decreases, you would have more deposition by letter A. Next, stream profile. Okay, at the outside of the curve, larger curve, the stream velocity increases, therefore erosion increases. Gradient along the bank is steep. Alright, so this first point pertains to this red line going across, right? This longer curve, or this larger curve. Right, that's your outside bank. So the most erosion would be right here by letter C in this case. Second point, at the inside of the curve, smaller curve, the stream velocity decreases, therefore deposition increases. Gradient along the bank is gentle. Right, so the smaller curve, right, the inside curve here is in green, and most likely by letter B would be your high deposition for this meander. Alright, and this is a good cross-section of a profile. So on the outside bank where it's steeper, you would have a very steep gradient here. Where you have deposition occurring on the inside curve, this would be a little more gentle. Well, actually gentle in comparison to the outside bank. Alright, meandering streams result in a asymmetrical profile. Right, so it's not the same on both sides. Let's go back. If I were to cut this profile in half and fold them on two sides, they would not be the same. However, for a straightaway, where a stream flows straight, those would be symmetrical in profiles, right? So if you fold them in half, they'll be the same on both sides, and that goes for all streams that are straight. Alright guys, so thank you for watching the video. Tomorrow you'll be taking your quick assessment and taking a whole bunch of questions from the regions pertaining to this lesson. Alright, have a good night.